Good day, students and parents! You are watching Valenzuela Facebook Live. Today, we are on our Quarter 3, Week 6 module, and we will be learning about the sum of interior and exterior angles of a convex polygon. Our learning competency for this lesson is to derive inductively the relationship of exterior and interior angles of a convex polygon. So what are these interior angles and exterior angles? Obviously, they are angles. But when do we say that it is an interior angle or an exterior angle? Let us take a look at this polygon. So what polygon is this? Correct. It is a pentagon, a polygon with 5 sides. So, any two adjacent sides of this polygon forms an angle. This angle formed inside the polygon is an example of an interior angle. In simple words, interior angles of a polygon are the angles on the inside. Then, we have another interior angle here, 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 and here. Therefore, all in all, a polygon with 5 sides or a pentagon also forms 5 interior angles. Now, if we extend this side of the polygon, it will form another angle to the adjacent side, and this angle is formed outside the polygon. So this is what we call an exterior angle. So, as simple as that, we say that an exterior angle is an angle that is formed by extending a side of the polygon. Moreover, if we extend another side of this polygon, there will be another exterior angle here, and also for this side, and that side, and also this side. So all these angles in blue color are what we pertain as exterior angles of this polygon. But take note that there are 2 sets of exterior angles for any vertex on a polygon. One going around clockwise, like what we did here, and the other set going around counterclockwise, like this one. Remember that whether you extend the lines going around clockwise or counterclockwise, these 2 exterior angles of the same vertex have equal measures. Now, we know the difference between interior and exterior angles. This time, let us differentiate convex polygon to non-convex polygon. For that one, let us see these examples. For us to know if a polygon is convex or non-convex, we try extending the sides of the polygon like this one. A polygon is convex if the extended lines of the polygon did not intersect the interior of the polygon, just like this polygon on your left. Therefore, it is a convex polygon. However, when we extend the lines of this polygon, if you notice, there are lines that intersects the inside of the polygon. So, when an extended line of a polygon intersects its interior, then it is a non-convex polygon. Get it? Good! Furthermore, all interior angles of a convex polygon measure less than 180 degrees. It is not necessarily equal to each other as long as all the interior angles of a certain polygon measure less than 180 degrees. However, the polygon is non-convex if one or more of the interior angle measures greater than 180 degrees, just like in this polygon on your right. So, those are the differences between a convex and a non-convex polygon. I hope you understand them very well. For us to check if you do, let us have a short exercise. All you have to do is to identify the following polygons as convex or non-convex polygon. Come on, let's do it together. Let us have the first one. What can you say about this polygon? Is it convex or non-convex? You are right. It is a convex polygon. Let us have the next one. It is convex or non-convex? Very good. It is also a convex polygon. How about this one? Good job. It is a non-convex polygon. How about for this one? Correct. It is also non-convex polygon. Now let us have this one. Very good. This one is a convex polygon. Finally, for our last polygon. Correct. This is a non-convex polygon. You did great, guys. I hope that helps you understand better the difference between convex and non-convex polygon. Now, let us focus on this triangle. Remember that the sum of the angles of a triangle is equal to 180 degrees. Whatever kind of triangle it is, as long as it is a triangle, the sum of the interior angles is always 180 degrees. How about a quadrilateral? What do you think is the sum of its interior angles? If you come to think of it, a quadrilateral can be divided into two triangles. And since the sum of the interior angles of a triangle is always 180 degrees, therefore, this triangle gives us 180 degrees and the other triangle gives us another 180 degrees. So for me to know the sum of the interior angles of a quadrilateral, that will be 2 times 180 degrees, which is equal to 360 degrees. This time, let us know the sum of the interior angles of a pentagon. Again, a pentagon can be divided into 3 triangles. And since the sum of the interior angles of a triangle is always 180 degrees, therefore, this triangle gives us 180 degrees. And the other triangle gives us another 180 degrees and another 180 degrees. So, for me to know the sum of the interior angles of a pentagon, that will be 3 times 180 degrees, which is equal to 540 degrees. Let us continue. What if we have a hexagon? What do you think will be the sum of its interior angles? Again, a hexagon can be divided into 4 triangles. And since the sum of the interior angles of a triangle is always 180 degrees, therefore, this triangle gives us 180 degrees and the other triangle gives us another 180 degrees, one more 180 degrees, and 180 degrees more. So for me to know the sum of the interior angles of a hexagon, that will be 4 times 180 degrees, which is equal to 720 degrees. Let us summarize our answers here and try finding the sum of interior angles of polygons with more than 6 sides. Like the heptagon, number of sides is 7 and can be divided into 5 triangles. Therefore, to know the sum of the interior angles, we should have 5 multiplied by 180 degrees, which is equal to 900 degrees. Well, for an octagon, number of sides is 8 and can be divided into 6 triangles. Then, we need to have 6 multiplied by 180 degrees, which is equal to 1080 degrees. A decagon, however, has 10 sides and can be divided into 8 triangles. Will sum up to 1,440 degrees. And a dodecagon, which has 12 sides and can be divided into 10 triangles, will sum up to 1,800 degrees. Have you noticed a pattern here? So, if we would like to compute for the sum of the interior angles of any polygon, denoted by n-gon with n sides, the number of triangles should be n minus 2. That is based on the pattern that can be observed here, wherein the number of sides minus 2 is equal to the number of triangles. So, to compute for the sum of the interior angles of a polygon with n sides, we need to multiply n minus 2 by 180 degrees. The sum of interior angles states that for any n-gon, the interior angles add up to n minus 2 times 180 degrees. With that being said, can you tell what is the sum of the interior angles of a nonagon? Of course, to answer this, it is very important that you know first what is a nonagon. If in case you did not know yet, a nonagon is a 9-sided polygon. So using the sum of interior angles, n minus 2 times 180 degrees, where n or the number of sides is equal to 9, using substitution, we replace n with 9. That will give us 9 minus 2 times 180 degrees. 9 minus 2 is 7. Then, multiplied by 180 degrees will result to 1,260 degrees. Therefore, the sum of the interior angles of a nonagon is equal to 1,260 degrees. Let us try another one. What is the sum of the interior angles of a decagon? So, to start solving this, you need to know how many sides are there in an endecagon. What do you think? You are right! An endecagon is an 11-sided polygon. So again, using the sum of interior angles, n minus 2 times 180 degrees, where n, or the number of sides, is equal to 11, by substitution, we replace n with 11, which will give us 11 minus 2 times 180 degrees. 11 minus 2 is 9. Then, multiplied by 180 degrees will result to 1,620 degrees. Therefore, the sum of the interior angles of an endecagon is equal to 1,620 degrees. Are you getting used to the process? If yes, that is really good. And if not, let us have one last example. What is the sum of the interior angles of a 100 gon? 100 gon is a 100-sided polygon. Using the sum of interior angles, n minus 2 times 180 degrees, where n is equal to 100, substituting, we replace n with 100. That will give us 100 minus 2 times 180 degrees. 100 minus 2 is 98. Then, multiplied by 180 degrees will result to 17,640 degrees. Therefore, the sum of the interior angles of a 100 gon is equal to 17,640 degrees. Now that we already know the difference between interior angles from exterior angles, also the difference of convex polygon to non-convex polygon, and the sum of interior angles, we will now proceed with the next concept that you need to understand for this week's lesson. And that is about regular polygons. So what are these so-called regular polygons? Try to take a look at these polygons. What can you observe? Correct. The measures of the interior angles of each polygon are equal. This is one characteristic of a regular polygon. A regular polygon is a polygon that is equiangular and equilateral. Equiangular means that all its interior angles are equal in measure. And equilateral means that all the sides of the polygon have the same length. For any regular polygon, the measure of each angle is n minus 2 times 180 degrees all over n, where n is the number of sides. When do we use this formula? This formula is used when you are asked for the measure of angles in a regular polygon. Let us say, for example, you are asked what is the measure of each interior angle of an equilateral triangle. If a triangle is equilateral, it also denotes that it is equiangular. Thus, an equilateral triangle is a regular polygon. Using n minus 2 times 180 degrees all over n, where n, or the number of sides, is equal to 3, we will substitute 3 to n, which will give us 3 minus 2 times 180 degrees all over 3. 3 minus 2 will be 1. Then, multiplied by 180 degrees is equal to 180 degrees. Then, divided by 3 will result to 60 degrees. Therefore, each interior angle of an equilateral triangle measures 60 degrees. Let us try answering another example. This time, what is the measure of each interior angle of a square? We know that a square has 4 equal sides and 4 equal angles. So, using n minus 2 times 180 degrees all over n, where n, or the number of sides, is equal to 4, we will substitute 4 to n, which will give us 4 minus 2 times 180 degrees all over 4. 4 minus 2 will be 2. Then, multiplied by 180 degrees is equal to 360 degrees. Then, divided by 4 will result to 90 degrees. Therefore, each interior angle of a square measures 90 degrees. This time, let us have the measure of each interior angle in a regular pentagon. Since it is a regular pentagon, it means that it has 5 equal sides and 5 equal angles. Using n minus 2 times 180 degrees all over n, where n is equal to 5, we will substitute 5 to n, which will give us 5 minus 2 times 180 degrees all over 5. 5 minus 2 will be 3. Then, multiplied by 180 degrees is equal to 540 degrees. Then, divided by 5 will result to 108 degrees. Therefore, each interior angle of a regular pentagon measures 108 degrees. Now, we already know how to compute for the measures of the interior angles. But how about the exterior angles? Remember that in a polygon, the angles formed by the sides inside the polygon are the interior angles, while the angles formed outside the polygon by extending the sides are the exterior angles. And each exterior angle is supplementary to its adjacent interior angle, which means that the sum of any exterior angle and its corresponding adjacent interior angle will always be 180 degrees. Like for example, in an equilateral triangle, whose each interior angle measures 60 degrees, the exterior angle will be 180 minus 60 degrees. That applies to the rest of the exterior angles. Take note that the number of sides of a polygon is equal to the number of exterior angles. So, to get the sum of the exterior angles of this equilateral triangle, we are going to add the measures of each exterior angles, which is equal to 180 minus 60 plus 180 minus 60 plus 180 minus 60 degrees. Simplifying, we are going to have 120 degrees plus 120 degrees plus 120 degrees, which is equal to 360 degrees. Therefore, the sum of the exterior angles of an equilateral triangle is equal to 360 degrees. Moreover, for a square whose interior angles measure 90 degrees each, the exterior angle for each is 180 degrees minus 90 degrees. So, to get the sum of the exterior angles, we will add 90 plus 90 plus 90 plus 90 degrees, or simply 4 times 90 degrees, which will be equal to 360 degrees. Furthermore, for a regular pentagon whose interior angles measure 108 degrees each, the exterior angle is 180 minus 108 degrees, or 72 degrees. Then, the sum of the exterior angles will be 5 multiplied by 72 degrees, which is equal to 360 degrees. Can you notice it now? That is what we call the exterior angle sum theorem, which states that the sum of the exterior angles of any convex polygon is 360 degrees. If the polygon is regular with n sides, this means that each exterior angle is 360 degrees divided by n. Let us try how this formula works. Let us say we need to know the measure of each exterior angle of a regular dodecagon. Do you know what is a dodecagon? Great! It is a 12-sided polygon. Using the exterior angle sum theorem, where n is equal to 12, we will substitute n to the formula. So, it will be 360 degrees divided by 12. And 360 divided by 12 is equal to 30 degrees. Therefore, each exterior angle of a regular dodecagon measures 30 degrees. See, it is very simple. Let us try once again for you to be familiar. What is the measure of each exterior angle in a regular heptagon? A heptagon is a 7-sided polygon. So using the exterior angle sum theorem, where n is equal to 7, we will substitute n to the formula. So it will be 360 degrees divided by 7. And 360 divided by 7 is approximately 51.43. Therefore, each exterior angle of a regular heptagon measures 51.43 degrees. Let us have one last example. What is the measure of each exterior angle of a regular 100gon? Do you still remember a 100gon? Very good. It is a 100-sided polygon. Using the exterior angle sum theorem, where n is equal to 100, we will substitute n to the formula. So, it will be 360 degrees divided by 100. And 360 divided by 100 is 3.6 degrees. Therefore, each exterior angle of a regular 100 gon measures 3.6 degrees. We are almost done, but let us recap first the concepts that we discussed for this week. First, we differentiate interior from exterior angles. Second, we also differentiate convex to non-convex polygon. Third, we have discussed three formulas: sum of interior angles, the polygon interior angle sum formula, and the exterior angle sum formula. Let us answer just a few practice questions for us to check how much you understand this week's lesson. Are you ready? Let us solve the following. For our first practice question, the interior angles of a pentagon are x degree, 2x degree, 2x degree, and 2x degree. What is the value of x? Do you have any idea what formula can we use? Correct! Since we are finding for interior angles of a non-regular polygon, we will use the sum of interior angles, which is n minus 2 times 180 degrees. Since the given is a pentagon, n, or the number of sides, is equal to 5. Substitute 5 to the formula, then we will have 5 minus 2 times 180 degrees. 5 minus 2 is 3. Then, multiply by 180 degrees is equal to 540 degrees. So, 540 degrees is the sum of all the interior angles of a pentagon. Since it was stated that the 5 interior angles are x degree, 2x degree, 2x degree, and 2x degree, when we add them, the sum is 540 degrees. So to find for the value of x, we have x plus 2x plus 2x plus 2x equals 540. Adding like terms will give us 8x equals 540. Since we are solving for x, we need to eliminate 8 by dividing both sides of the equation by 8. And that will give us x is equal to 67.5. You are doing well. For our second question, the interior angles of a polygon add up to 1,980 degrees. How many sides does it have? In this case, we will be using the sum of interior angles. The sum of interior angles is given. That is 1,980 degrees, which means that n minus 2 times 180 is equal to 1,980. Our unknown is the number of sides. That is why we are solving for n. So, by distributive property, we multiply 180 to the numbers inside the parentheses. That becomes n times 180 minus 2 times 180 is equal to 1,980. Simplifying this equation will give us 180n minus 360 equals 1,980. Since we are solving for n, we need to isolate the n variable to the right-hand side of the equation and eliminate negative 360. To eliminate negative 360, we will apply the addition property of equality and add 360 to both sides of the equation. That will be 180n minus 360 plus 360 equals 1,980 plus 360. Simplifying this will be 180n equals 2,340. To solve for n, eliminate 180 by dividing both sides of the equation by 180, which will result to n equals 13. Therefore, the polygon whose sum of the interior angles is 1,980 degrees is a polygon with 13 sides. For our third question, what is the value of y in the given illustration? Try to observe first the illustration before solving. As you can see, y here is a representation of an angle measure. But what type of angle is it? Great! Y is an exterior angle. Same as the other measurements shown. 60 degrees, 70 degrees, 65 degrees, and 40 degrees are all measurements of the exterior angles of this given polygon. Since we are now dealing with exterior angles, we will be using the exterior angle sum theorem, which states that the sum of the exterior angles of any convex polygon is 360 degrees, which simply means that if we add all these exterior angle measures for this polygon, they should sum up to 360 degrees. Then, let us start solving by adding 60 plus 70 plus 65 plus 40 plus y equals 360. Simplifying this, we will have y plus 235 is equal to 360. Since one of the exterior angles is unknown, we solve it by isolating y on the right-hand side of the equation by eliminating 235. Applying subtraction property of equality, we subtract 235 to both sides of the equation, which gives us y plus 235 minus 235 is equal to 360 minus 235. Simplifying, we will have y is equal to 125. Good job! I believe you can solve more of these problems on your own. Let us recall some of the terms that we discussed for this week's lesson. You name it to win it. All you have to do is to name or identify the terms that are being determined by the following statements. Are you all ready? Let us start. Question number 1. These are the angles inside a polygon. Very good. It is interior angles. Question number 2. These are the angles that are formed by extending a side of a polygon. Correct! Exterior angles. For our question number 3, it states that for any polygon with n sides, the interior angles add up to n minus 2 times 180 degrees. Great! It is sum of interior angles. Doing good. Let us have question number 4. These are polygons in which all of its sides and all of its angles are equal. You are right. It's regular polygons. Finally, for our question number 5, it states that the sum of the measures of the exterior angles of any polygon is 360 degrees. Correct. The answer is exterior angle sum theorem. So how was that? Did you answer them all correctly? Great job! For our last task for this week's lesson, try answering these questions for your self-assessment. You will be given 5 seconds for each question. First, what is the measure of each exterior angle of a regular octagon? Time's up. The answer is 45 degrees. Next, what is the measure of each exterior angle of a regular decagon? Time's up. The answer is 36 degrees. For our next question, what is the sum of the exterior angles in a regular 15-gon? Time's up. The answer is 360 degrees. For the fourth question, what is the measure of each angle in a regular hexagon? Time's up. The correct answer is 120 degrees. And for our fifth and final question, the sum of interior angles of a polygon is 1,800 degrees. How many sides does it have? Time's up. The correct answer is 12 sides. How did that go? Is it 5 over 5? For our thought to ponder, the best angle from which to approach any problem is the triangle. Remember that whenever we are faced with problems or difficulties, all you have to do is to keep trying different methods or things until you find one that works. That concludes our lesson for Quarter 3, Week 6, about the sum of interior and exterior angles of a convex polygon. I really hope that you learned something from our discussion today and apply it in answering your modules and, who knows, in real life also. Again, this is Ma'am Christine for Valenzuela Facebook Live. Keep safe and healthy to answer your modules correctly.